Imagine a world where you never have to blindly trust an expert ever again. It's like no trusting a politician when they say a bill is going to help you,
Right.
or taking a financial advisor's word as absolute gospel.
Or assuming a doctor's diagnosis is completely flawless just because, they have a fancy framed diploma on their wall.
Exactly. And not because these people are inherently malicious, but because you suddenly possess a tool that instantly proves whether their claims actually align with reality.
You wouldn't need to take that invisible leap of faith anymore.
Yeah, you really wouldn't. And today, we're taking a deep dive into a really fascinating collection of notes and excerpts titled Statistics is Mathematized Epistemology.
Which I know sounds heavy.
Yeah, right? Before you let the word statistics trigger like traumatic flashbacks to high school math, stick around. Because today's sources blend philosophy, mathematics, and cutting-edge tech to explore something much bigger.
It's really about how we actually know what we know.
Yes. The mission of this deep dive is to uncover how AI and statistical reasoning are teaming up to just completely dismantle the world's knowledge monopolies.
We're looking at a fundamental shift in how you navigate the world, moving from a society where you're forced to blindly trust experts to one where you are empowered to actually verify reality for yourself.
Okay, let's unpack this, because framing statistics not as some dry spreadsheet tool, but as a roadmap to understanding modern power dynamics.
Yeah.
That is quite the pivot. So let's start at the very foundation. The core argument in our sources is that statistics is literally mathematized epistemology.
Which is a mouthful.
It is. Now, epistemology is the philosophical study of knowledge, right?
Yeah.
Like, it asks what the difference is between a justified belief and just a random opinion.
That is exactly the dividing line. Philosophers have argued about this for centuries. I mean, think about thinkers like David Hume or Charles Sanders Peirce.
Bro.
They wrestled endlessly with these abstract concepts of truth and uncertainty. Like, how can we ever be certain about the physical world given that our senses are, flawed?
Right, our eyes play tricks on us.
Exactly. And the source material highlights David Salsburg's work, The Lady Tasting Tea, which argues that statistics actually emerged to solve this exact philosophical crisis.
Wait, really?
Yeah. Statistics wasn't invented just to count things. It was invented to formalize epistemology.
So it basically put hard numbers to philosophical uncertainty. It's like a truth decoder ring for philosophers.
That's a great way to put it. It gave us a way to take human uncertainty and turn it into structured, reliable knowledge. E.T. Jaynes takes this even further in his work on probability theory.
Okay.
He argues that Bayesian statistics is the mathematical completion of classical epistemology. He explicitly frames probability as like an extended logic.
Wait, slow down for a second. Let's make that concrete for the listener. When an engineer looks at a newly built suspension bridge and says, I am 95% sure this bridge will hold, what are they actually doing in that moment?
Well, they are using engineering principles, sure. But the statement itself is pure epistemology with numbers.
How so?
They are admitting that total 100% certainty is impossible. A hidden flaw could exist in the steel, or, an unprecedented hurricane could hit.
Right, the unpredictable real world.
But instead of throwing their hands up in philosophical despair, they use statistics to quantify the uncertainty. They're turning the chaotic physical world into a structured percentage of truth.
I see. So the underlying statistical machinery, things like confidence intervals or probability distributions, these aren't just academic hurdles you have to jump over.
Not at all.
They're the actual mechanisms we use to evaluate reality.
Yes, and they form the most reliable truth filter humanity has ever created.
Which brings me to a huge point of friction. If statistics is the ultimate objective framework for finding the truth, why is there that famous saying, lies, damned lies in statistics?
Yeah.
Because honestly, it feels like politicians, corporations, and even scientists use math to lie to us all the time. If the math is so pure, why is the output so often garbage?
What's fascinating here is that the math itself is completely pure. The method is totally sound.
Okay.
The issue is the human operating the math. Nate Silver explores this heavily in his book, The Signal and the Noise. He points out that while statistical methods like Bayesian logic are perfectly valid,
We humans constantly distort them.
exactly, we have internal biases, we have massive financial incentives, and frankly, we have egos to protect.
So we naturally corrupt the process. And the irony is we actually use this kind of statistical reasoning informally in our own heads every single day, right?
We do.
There's that concept from Daniel Kahneman's Thinking, Fast and Slow, and Richard Bickelreith's work on statistical rethinking, They show that we are all just walking, talking, informal statisticians.
Yeah, the technical term for it is Bayesian updating. It's simply the process of changing your beliefs as you get new evidence.
Let me try an analogy here to see if I'm getting the mechanism right. Bayesian updating is basically like a GPS navigation app on your phone.
Okay, I like where this is going.
When you start a road trip, the GPS has a prior belief about when you'll arrive, say 5:00 p.m., based on the speed limit.
Right.
But as you drive, it constantly pulls in new data. It sees that hundreds of cell phones on the highway ahead are only moving at 15 miles per hour. It doesn't have a crystal ball, but it takes that new evidence, updates its original belief, and calculates a new arrival time of 5.45.
It just relentlessly optimizes the probability of the truth based on the newest evidence. That is a brilliant way to explain it.
Thanks.
You have a prior belief, you receive new data, and you generate an updated belief. We do this without equations all the time.
Like with people we trust.
Exactly. Think about a weather forecaster on your local news. If they predict rain and it actually rains, you trust them a bit more. If they're consistently right for a year, your brain updates its belief and you inherently trust their next prediction.
So you're literally running a Bayesian model in your head.
You are. But here's where the human flaw comes in. A GPS doesn't get emotional about the traffic.
Right.
But Kahneman points out that our brains are riddled with systematic biases. We might remember the one time the weatherman was wrong and completely forget the 99 times he was right.
Just because that one time we got caught in a downpour wearing a nice suit and we're like still mad about it?
Exactly. Our internal math gets corrupted by emotion and limited memory. But it gets even worse when professional incentives are introduced.
Oh, I bet.
This is the crux of John Ioannidis' famous paper, Why Most Published Research Findings Are False. He proved that false knowledge usually doesn't come from broken math.
It comes from the misuse of perfectly good math.
Yeah.
How does that actually work in practice, though? Because that sounds like a massive accusation against the scientific community.
Let's look at the mechanism. Imagine a pharmaceutical company running a clinical trial for a new drug.
Yeah.
The statistical tools they use, the p-values, the likelihood ratios are flawless. But the humans running the trial have a billion-dollar financial incentive for the drug to work. So they might engage in what's called cherry-picking or p-hacking.
Which means what, exactly?
It means they might test the drug on 20 different demographic groups. Just by random statistical noise, the drug might appear to have a positive effect on one of those 20 groups.
Oh, wow.
The math is just reflecting random chance, which is what it's designed to do. But the researchers only publish the data from that one group and quietly hide the 19 failures.
Wow. So they use the pure math to tell a highly biased story. The GPS is functioning perfectly, but the person reading the screen is just lying to you about what time you're going to arrive.
Precisely. Which is why the saying shouldn't be lies, damned lies, and statistics. It should really be statistics doesn't lie, but people with incentives absolutely do.
So if human bias and bad incentives are the bug in our informal Bayesian updating, what happens when a system comes along that can do the math perfectly, at scale, and without any of those human flaws?
That is the pivotal shift we're living through right this second. We are entering an era where epistemic authority, meaning who we fundamentally trust to tell us what is true, is shifting rapidly.
Shifting away from human credentials and toward AI accuracy.
Yeah.
Here's where it gets really interesting, because we are talking about fundamentally redefining what makes someone or something an expert.
Right.
We have this deeply ingrained cultural idea that expertise comes from prestige, a degree from an Ivy League school, a title, a corner office.
But Philip Tetlock's research on superforecasting completely upends that. He proved that epistemic authority over time is determined by one thing and one thing only. Exactly. Accuracy. And Norbert Wiener, the father of cybernetics, saw this coming decades ago. He envisioned systems that would eventually vastly outperform human experts in complex prediction.
Why? Just because they're faster.
Because these systems operate on pure feedback loops and scaled statistical inference. And AI doesn't have an ego. It doesn't get tired.
It doesn't have a mortgage to pay.
Right. So it doesn't need to secure funding by publishing a flashy, cherry-picked research paper. It just ingests massive amounts of data, rigorously updates its probabilities, and outputs the most accurate prediction possible.
I hear that, but let me play devil's advocate for a second.
Go for it.
Are we really just going to trust an algorithm over a doctor who went to medical school for a decade? I mean, human biology is messy. There's a human element to expertise.
Like intuition.
Yeah, intuition, reading between the lines of a patient's symptoms. Are we seriously saying a machine takes over just because it has a better batting average?
It's a very natural pushback. We want to believe human intuition is magical. But let's look at the mechanics of why relentless accuracy naturally erodes traditional authority over time.
Okay, play it out.
A top human doctor can read maybe a few dozen medical journals a year. They have a limited cognitive capacity to remember drug interactions and historical case studies.
Sure, they're only human.
But an AI system can ingest the entirety of recorded medical history. It can cross-reference millions of patient outcomes and update its Bayesian probabilities in milliseconds.
So it's just an unfair fight in terms of data processing.
Completely unfair. If an AI system consistently diagnoses a rare cancer from an MRI 3 years earlier than a panel of top human specialists,
Wow.
and it does it with 99% accuracy while the humans hit, say, 80%, where does your trust eventually go?
Honestly, if it's my life or my family's health on the line, I don't care about the doctor's Ivy League diploma. I'm going with whoever is right more often.
And that is the exact shift. As AI begins to predict weather patterns, navigate complex financial markets, optimize global logistics, and diagnose diseases far more accurately than human experts.
The trust naturally shifts toward the machine.
Yes, this shift isn't driven by some grand ideological tech agenda. It is driven by pure, undeniable performance. The AI is simply a better, uncorrupted Bayesian updater than the human brain.
Okay, but if trust shifts to these hyper-accurate AI systems, what happens to the massive human institutions whose entire business model relies on being the exclusive gatekeepers of complex knowledge?
That is the million-dollar question.
Right, because I'm thinking about the legal industry, the healthcare administration bureaucracy, the tax preparation industry.
If we connect this to the bigger picture, this is where we see the collapse of a concept called security through obscurity.
Oh, this is fascinating. The sources draw on James C. Scott's work here, right? Explain how institutions use obscurity as a weapon.
So Scott argues that institutions maintain their power and authority largely by making their internal processes incredibly opaque to the public.
Like intentionally confusing.
Exactly. If a system is so dense and confusing that you can't possibly understand how it works, you have no choice but to rely on the institution to navigate it for you.
You have to pay their fees, accept their timelines, and just trust their outcomes.
It's the ultimate gatekeeping.
Yeah.
And Bruce Schneier, the famous security expert, writes about this extensively. He points out that security through obscurity, which means hiding how a system works to maintain control over it, is an incredibly fragile strategy.
Because it relies on ignorance.
Right. It only works as long as the public lacks the tools to decode the complexity. The second that information becomes legible and democratized, the whole monopoly instantly collapses.
Man, society has allowed these institutional gatekeepers to thrive purely because the average person didn't have the statistical or analytical capacity to parse the complexity.
Think about the tax code. It's thousands of pages of cross-reference jargon. Or look at medical billing. It is just a labyrinth of obscure codes and negotiated rates.
Yes. Anyone who has ever tried to read a hospital bill after a surgery knows exactly what you mean. It feels like it was intentionally written in a foreign language.
Just to force you to hire a medical billing advocate or just give up and pay the exorbitant fee.
The sheer complexity maintains the industry's power. The complexity isn't a bug. The complexity is the product.
That is the perfect way to phrase it. But let's look at how AI dismantles this. How does an AI read a convoluted 500-page legal document or a massive database of opaque medical billing codes?
It uses those exact same statistical tools we talked about earlier.
Right. It uses probabilistic language models to map the relationships between dense jargon and plain English. It untangles the web instantly.
So suddenly you have a tool on your laptop that can look at that hospital bill, instantly cross-reference it against the entire history of healthcare pricing, flag the intentional overcharges.
And draft a perfectly cited legal letter to the hospital disputing the charges.
That is wild. The monopoly just dissolves.
Yeah.
You don't need the human gatekeeper anymore because you finally have a tool that can decode their artificial complexity.
The walls of the walled garden fall down. The institution's power was never actually based on adding value. It was based on epistemic scarcity, a deliberate lack of accessible knowledge.
And once AI removed that scarcity by doing the heavy statistical lifting for you, the institution's unearned authority simply vanishes.
Yes.
So what does this all mean for you, the listener? If these old gatekeepers are collapsing, what do you actually get out of it?
What you get is a reality the source material refers to as epistemic succession.
Epistemic secession. That is a heavy, powerful phrase. It sounds like a Declaration of Independence.
In many ways, it is a quiet intellectual revolution. It draws heavily on Elinor Ostrom's Nobel-winning work on decentralized governance.
Okay, what did she find?
She showed that when everyday people actually have the tools to understand and manage complex systems themselves, they naturally stop needing centralized authorities to dictate terms to them.
And Clay Shirky echoes this exact sentiment in his book, Here Comes Everybody. He describes how access to information and organizational tools allows the public to completely bypass traditional institutions.
Let's play this out with a really grounded example from the text. Imagine a massive, highly partisan, 1,000-page piece of legislation that gets dropped in Congress 24 hours before a vote.
Historically, that's a task that required a small army of specialized lawyers and lobbyists just to figure out who it benefited and who it hurt.
Right. And the average citizen just had to trust whatever their preferred politician said on television about the bill.
But now imagine feeding that legislation into an AI.
The AI reads it instantly, but it doesn't just summarize the text. Because it is a massive statistical engine, it can mathematically model the real-world effects of the policies.
Right.
It can cross-reference the proposed tax changes against historical economic data. It can compare the bill to alternative policies from other countries.
It could probably flag hidden loopholes buried in, like, subsection 402.
Exactly. And then explain the entire objective reality of the bill to you in plain language while you drink your morning coffee.
In that scenario, citizens no longer need intermediaries. You don't need lobbyists or bureaucrats or partisan pundits on cable news to interpret reality for you.
No.
You don't have to trust the politician who says this bill will lower your taxes because you have the tools to verify exactly what the bill does yourself, down to the penny.
That is the essence of epistemic succession. It is the ability for everyday people to literally exit the old knowledge
They're
hierarchies.
seceding from the monopoly.
Exactly. You no longer have to live in a world where you just blindly trust the experts because you finally have the power to verify the truth independently.
It's the ultimate democratization of statistical reasoning. The AI serves as a perfect lens. It removes the human bias and the perverse financial incentives that Nate Silver and John Ioannidis warned us about.
Yeah.
And it takes that pure mathematical epistemology that David Salsburg described and puts it directly into the hands of the public.
It is incredible when you pull all these threads together. We started with this deeply abstract philosophical problem. Like, how do we know what is true?
Right.
We saw how statistics gave us a mathematical framework to find the truth, and how human bias constantly corrupted that framework to build institutional monopolies hidden behind confusing jargon.
And we arrived at a near future where AI steps in as the ultimate uncorrupted Bayesian updater. It strips away the obscurity, does the math perfectly, and collapses the walled gardens of these complex industries.
This completely changes your position in the world. As a listener, you are no longer at the mercy of opaque, confusing systems.
You aren't forced to rely on a gatekeeper just because they have a fancy title or control a process you don't understand.
No, the tools of verification are literally in your hands. You get to demand evidence, and more importantly, you finally have the ability to understand that evidence without a translator.
It's an incredibly empowering shift. We are moving from trust me to show me the data. But as with all massive technological shifts, it brings its own unprecedented challenges.
It certainly does.
And I know you have a final thought on this that builds on everything we've covered today.
I do. This raises an important question, and it's something I want to leave you to ponder as you navigate this changing landscape.
Okay, let's hear it.
If AI perfectly democratizes knowledge and gives everyone the power to instantly verify the truth, what happens when two different people use two entirely different AI systems?
Wait, what do you mean?
Well, imagine both AI systems are operating on flawless statistical math. The algorithms are perfect, but they were trained on slightly different historical data sets. Because of that variance in their prior beliefs, they arrive at completely different yet mathematically verified realities.
Oh, wow. That is a wild thought.
When the monopolies completely collapse and everyone has the ultimate truth filter right in their pocket, who do we trust when the truth filters disagree?
That is the question, isn't it?
When the bridge metaphor we started with breaks down and one AI mathematically proves the bridge is 99% safe, while the other AI mathematically proves it is guaranteed to collapse, When everyone can verify the truth, what happens when there is more than one truth?
Man, that is the wild new frontier of epistemology right there. What a fascinating and slightly terrifying place to leave it. Thank you so much for joining us on this deep dive. Until next time, keep questioning and keep verifying.